In this video, we are going to talk about the scientific method. Now, the scientific method is a way scientists approach a problem. I saw this quote about crime investigation, and I thought it was very valuable. And it really shows us that observation is the most important skill of a forensic scientist. And that is because there are so many different opportunities that a criminal can have to leave behind evidence. The scientific method is used by scientists, and it is just a systematic way to approach a problem. So it is a systematic way for problem solving. And it is used by forensic investigators, scientists who are investigating crimes to prove what happened at a crime scene. Now, there are many steps to the scientific method. Step one is where you make an observation, and that observation causes you to ask a question. So it's something that makes you go, I wonder what's going on with this. So after you ask your collection, or after you ask your question, you can start collecting and analyzing data. After you've done that, you have something to go off of. So step three is where we form a hypothesis. Now, a hypothesis is an educated idea. All right. So it's not just an idea because you've already collected some data, you've collected some evidence, and you've analyzed some of that evidence. So it's not just an idea, it's an educated idea. All right. And so after you've formed that hypothesis, you need to test your hypothesis. And this is where we perform experiments. Now, when you are performing these experiments, you need to be aware that you also have to design them. So you have this idea, and now you need to come up with a way to test your idea. Now, in step five, if your hypothesis holds up to testing, then you are finished. And that in science is where it can turn into a theory or a law. A very common misconception is that a theory is not, quote unquote, as strong as a law, or a theory can be disproved and a law cannot. However, theories and laws have gone through the same exact process. They are proven and they have the same, quote unquote, strength. And so new evidence can come along and change a theory. New evidence can also come along and change a law. Now, when we talk about the scientific method, a lot of times we list it as this systematic way to approach a problem, and it is step by step by step by step by step. But as you can see in this figure here, it really doesn't go in a stepwise form. It's more of a cycle. So you can make an observation, and after you've made that observation, then you go and you collect and analyze all the relevant data. From there, you can form your hypothesis. You can make your idea and have some sort of evidence to back up that idea. Now, after you do that, then you design your experiments to validate your hypothesis. If your experiments prove to validate your hypothesis, then you are finished and we can form a theory or a law. If it is not, if your experiment does not validate your hypothesis, then you start over. You look at your data, you can form a new hypothesis, and then you can form new experiments. Also, sometimes if this is a no, you don't really need to form a new hypothesis. You don't really need to collect that initial data. You can just go back and redesign your experiment. And so you get this process happening right here a lot where your experiment doesn't do what you thought it should do, so you have to go and tweak it a little bit.